All right, let's go ahead and take a look at today's topic, which is compound interest. As we take a look at this, there's a formula associated with this topic. I want everybody to write that down and understand what the letters represent in this situation. One of the most important things that we need to discuss is this compounding period right here. That's something new that we have not seen yet before in an exponential function. So if something is compounding more than once in a year, we need to represent that in this formula. Let's go ahead and put this into practice. Okay, everybody read this situation. You're going to have $500 put into a bank account. It's going to earn 9% interest. And it's going to be left in the account for 2 years. Now, the thing is, there are possible different compounding periods. So let's go to part A, and let's see if we can figure this out, okay? So the amount that we're looking for is going to be equal to the principal, the beginning amount, which is $500. Now that's going to be multiplied by 1 plus, remember that 1 represents the 100% of the original amount. Here's my interest rate, 9%. Got to be written as a decimal. Now the next thing we're supposed to do is divide this by the compounding periods. This is yearly. That's just once in a year, isn't it? So there's going to be a 1 there. Close your parentheses, and then your exponent is going to be n, or your compounding periods, times how long is it in the account? 2 years. Now, look at that exponent. 1 times 2 is just 2, isn't it? So why don't we make this simplified a little bit? Let's just put a 2 there. Now, let's go ahead and calculate this. How much money is in this account after 1 year if you only compound it 1 time? Type it in very carefully. There's my 500 parentheses. 1 plus my interest rate, 9%, divided by 1 compounding period. Close your parentheses. Very crucial, make sure you're using an exponent. In this case, I have a 2. And it's $594.05. All right, let's move on to part B. The only thing that's different is that this is going to be compounded semi-annually. So let's get our formula. It's still $500. It's still 9% interest, but semi-annually means twice per year. Okay, that's crucial. My exponent now is twice per year at 2 years. So 2 times 2 is actually 4, isn't it? So let's change this exponent to a 4. And let's see how much money we have if we compound it twice a year instead, with all other things being the same. So there's a couple ways you could do this. You could just type your formula in again, or you could edit it. Whatever you want to do is fine with me. I'm going to divide this by 2 this time. And now my exponent is actually a 4 because there's 4 compounding periods. So I see it looks like I got a little bit more money, $596.26, if you round carefully. Interesting. All right, let's keep this moving along. What about if we compound quarterly? Okay, everybody see this? Think about what quarterly means. All right, let's go ahead and calculate. So my amount is still $500. The interest rate is still at 9%. However, quarterly means it's going to be applied 4 times a year, and it's going to be still for 2 years. So it's actually going to be, look at this, 8 compounding periods, isn't it? Let's make that an 8 up here. So we're compounding more often. Let's see what happens to the money now. All right, here we go. Let's calculate again. Divided by 4, exponent of 8. Okay, we got a little bit more money, $597.42. Now, finally, about monthly. What about monthly? How many times per year is that? That's right, it's 12, isn't it? Same formula. However, this denominator is going to change to a 12. So that exponent is actually going to be a 24. All right. How much money do we have now? Let's see. $500 at 9% compounded monthly with 24 compounding periods. Whoa, $598.21. All right, so let's take a look at all this. Might need to shrink this down a bit. There they are. There's all those cases. So check it out. We can see that the more times you compound, the more money you get. Keep that in mind in life. Let's try something else. What about this situation? So you deposit $9,000 in an account, pays 5.46 annual interest, pretty good rate. Could be a certificate of deposit, maybe a stock market fund, who knows. Find the balance 3 years later when the interest is compounded daily. All right, let's set up a formula for this. All right, how much money are we starting with? $9,000. What's our interest rate? Now remember, you got to change that into a decimal. So move that over 2 places. Now the next thing is, how many compounded periods are there? Daily. 365 we use for that in 1 year. 365, right? And then our exponent will be 365 times, how many years is it in there? It says right here. 3 years. All right, so let's go to our calculator, carefully type this in. Let's see what this answer is this time. So let's start with 9,000. Interest rate, be careful, 0.0546 divided by 365 days. Okay, at this point, be really careful with your exponent. You might want to put it in parentheses. I think I will. 365, just to be safe, times 3. All right, so that should be good. Okay, we're going to have $10,601.68. Well, let's remember that. And let's go down to the next question here. It's about simple interest. So I think I'm going to just slide this up here so we can see it. So it says, well, what's the balance on the account in the same situation if simple interest is used instead? So I'm going to show you a formula. Here's the formula for simple interest. So what these represent is the I represents the amount of interest that you are going to accrue in this situation. The P is the principal, which we know from above is 9,000. So I'll put that in parentheses. Everything's being multiplied together. R is my interest rate as a decimal, which is 0.0546. Time is 3 years. Now, simple interest means that the interest is only applied one time. Let's see what the interest is in this case and compare it to the interest that we have up in the compounding interest formula. And we'll talk about that in just a second. So there's my 9,000 times 0.0546 times 3. Okay, so we get 1,474 and 20. Now, the question is, what's the new balance on this? So the new amount will be the original plus that 1474. So it would be that plus the original 9,000, which will be 10,474.20. Now let's make a comparison here between those two amounts so that we can determine the difference between these types of interest. So we can see the compounding gives us a much larger amount within a 3-year period. So if you have the opportunity to invest in different ways, I would definitely go with compounding interest over simple interest. Simple interest is more like linear growth as compared to exponential growth.